All right, so the next conic that we're going to talk about, last couple days we've been talking about parabolas. You have horizontal and vertical parabolas. All right, now we're going to talk about ellipses. That's what that word says, an ellipse. We have vertical and horizontal ellipses. Some of you guys may refer to this as an oval, right? Looks like a circle that got smushed. Everybody see that? An ellipse, the definition is a set of all points, x and y in a plane, that sum of whose distances from two distinct points, the foci is constant, right? That says foci. If you have one, it's a focus. Two is a foci. All right, so let's just look at these pictures. You guys are not going to have to memorize this, but you have to understand what this is looking at. Do you see the difference? On the left side is the horizontal and the right side is the vertical. Why is the left one a horizontal? Because it's wider, right? Do you see how it's wider? The vertical one looks like if someone's been pulling it from the top, maybe. All right, so we're going to talk about three very distinct, very important values. The A value, the B value, and the C. All right, your vertex on the horizontal, your vertex is on the x-axis. Do you guys see right here? Your A. And we'll talk about how to find all this and all that. On the vertical, it's on the y-axis. Do you guys see that? All right, that determines what kind of an ellipse you'll have. So you'll see which formula you're going to use. But that is called your major axis. Wherever, if it's a horizontal, then your major axis is going to be the longer one. If it's a vertical, then your major axis is going to be in the y. Covertices, that's going to do with your B value. And then you have something called the foci, which is your C value. And again, we'll talk about this in a second. We're going to talk about the equation. Let me write this down for you guys. This is for the horizontal, and this is for the vertical. I want you to notice what the difference is, because you're going to have to be able to recognize what is different to tell you what kind of an ellipse you have. What is different about these two formulas? The B and the A are switched. Uh-huh. Notice, wherever the A is determines what kind of an ellipse you have. Do you see here that the A value, and you'll see what I mean by that in a second, is underneath the x squared? That's what makes it horizontal. Do you see here the A value is underneath the y squared? That's what makes it vertical. Is that a major difference? No, it's a tiny little nuance which makes things very difficult sometimes at the beginning to understand. So just stay with me. You're going to have to practice this more and more, and the more we do it, the easier it'll get, I promise. All right, so let's look at the next. This is the exact same thing. Talking about the same thing as the picture just did. It kind of puts it in a chart form. The only thing I would say is I would cross this off, and I would rewrite what we just wrote over on the last slide. X squared over B squared plus y squared over a squared equals 1. It's easier to remember that way. But notice the distance from the center. When our center is at 0, 0, we didn't move anywhere. We'll find the center in a minute. It's very similar to a parabola. But to find your vertices, it's the A value. How far from the center are your vertices? The B value is how far your covertices are. And the C value is how far the foci are. All right, another important piece of information is right here. What does this kind of look like? Kind of looks like the Pythagorean theorem. Is it the same as the Pythagorean theorem? No, because why? There's a minus, okay? So you got to remember that. But to find the C value, you use the formula C squared equals A squared minus B squared. And then if they tell you that the length of the major axis is whatever, or the length of the minor, remember major is the important one that goes with A. So the length of your major axis is 2 times your A value. The length of the minor axis is 2 times your B value. Right, now I just want to kind of put this into motion to kind of see how this is not crazy difficult, I promise. It's just a lot to look at. All right, it says right here, here's an example. You're going to graph, find the vertices, the co-vertices, and the foci. So let's talk about this for a second. First of all, vertices goes with which value, A, B, or C? A, good. Co-vertices goes with the B, and the foci goes with C, okay? Think about what you what you're looking at. We're going to identify the A, B, and C here, but we first have to make sure this is in standard form. Is it? Angel, what did you ask me when I wrote down the formula? You said, does that equal 1? Does it equal 1? Guys, does this equal 1? No. How could we get it to equal 1? What would we have to divide everything by? 64. Always make sure, because it has to be in standard form, it has to be x squared plus y squared. It has to be in the standard form of x squared over a squared plus y squared over b squared equals 1, or with the a and the b switched. But you have to, first thing, if you have a number here that is not 1, what should you do? Divide everything by it. So when I simplify this, what does my x squared become? What does that simplify to? X squared over what? 16, okay. Plus y squared over, okay, equals what? Perfect, okay. So here we are. It's our standard form of an ellipse. So now we're going to talk about our A and our B and our C. What did I tell you about how to figure out if this was vertical or horizontal?
If the A was under the x or the y.
Okay, if the A is under the x squared, it's a vertical. If the A is under the y squared, it's horizontal. A is going to be your bigger value. Which one is bigger here, guys? The y squared. So this is your a squared, and this is your b squared. So what did we just determine there again? That this is what kind of an ellipse? This is a vertical. The bigger one is A. All right, it's really important to kind of think through this. The computation behind this is not hard. So what I would do is I personally would say, okay, a squared, over here I'm going to say a squared equals 64, b squared equals 16. So what is the value of A? What kind of 8? Plus or minus 8, good. What is the value of B? Plus or minus 4, okay? So what is that telling us? Remind yourself, if you need to, as we go through this. This is vertices, and this is the co, right? So from the center, how far away is your vertex? How many units? Plus or minus 8, right? So how far away is your co-vertices from the center? Plus or minus 4, right? Do you see how that makes, so if you guys wanted to, you could start saying, okay, all right, let me give myself a little picture here, because pictures are very helpful. Where is the center of this hyperbola? It's at 0, okay. What kind of, excuse me, what kind of a ellipse did we say it was? Vertical. So your major axis is going to be which? The y or the x? The y. So I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's a vertex. And then I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Everybody okay with me? How do I find my co-vertices? Those are the ones like, they're sub, less than. Which way would I go? From the center. Right, 4. 1, 2, 3, 4. We'll call it the co-vertice. And then I'd go where? To the left 4. 1, 2, 3, 4. So side note, just if you were thinking, okay, well, how's this going to be different when we're at the center, when the center's on at 0? If you're going to move up and down, you add and subtract the value to the y. If you're going to move left and right, you add and subtract the value to the x. That's all the difference is. All right, everybody okay so far? Okay. If you wanted to draw a little picture, you could, right? It's going to go through the vertices and the co-vertices. And then what's the last thing we need to find? We found the vertices. You guys can tell me where they are, right? What is this point up here? 0, 8, right? What's this one down here? 0, negative 8. Perfect. What's this point over here? 4, 0. What's this one? Negative 4, 0, right? Now, how do you find the foci? Well, it's from the center. It's the C value. What was that little formula we had for the C value? C squared equals A squared minus what? B squared. Well, guys, what is A squared? 64 minus, what is B squared? 16. So C squared equals what? 48. And I take the square root. So C equals 16 times 3, so 4 root 3. Plus or minus, should have written. Plus or minus 4 root 3. So where is the foci? Look back on your little chart or whatever. Is the foci on the same axis as the major or the minor? Look back at the picture. It's on the major. All the important stuff is on the major axis. So how would you figure out from the center where the foci is? If my center's at 0, 0, how would I get to the foci? Is that the x-axis or the y-axis? Are we moving up and down? Are we moving left and right? Up and down. Very good. Because the foci is on the major axis. If this is a vertical ellipse, the major axis is the vertical. So your foci would be at 0, 4 plus root 3 and 0, 4 minus root 3. So somewhere in the middle. It's always going to be on the inside. Which way does your parabola open? Which way is the parabola open? Towards the and away from the. So when you have your focus, two focuses are two foci. Where are they going to be? Inside the ellipse or on the outside? Inside, always. So to do this is not incredibly difficult, but there are little steps you have to take, or else you get yourself super duper confused. Does anybody have any questions right now?
How do you know where the foci? Like specific number wise? Because
I just estimated. That was just an estimation. Yep.
Would it be 4 minus root 3 or minus 4 root 3?
Oh yeah, you're right. I put the minus in the wrong spot. Sorry. 0, right? 4 root 3. And then 0, negative 4 root 3. All right, let's do another one. Let's talk about this. Just look at it. How do you know? And you'll see when we do hyperbolas next. A hyperbola, and we'll talk about it in a minute. Not in a minute, but in a few days. A hyperbola is the opposite of an ellipse. An ellipse is like an oval that comes together like that. A hyperbola is like this. They go in opposite directions. We'll talk about that later, though. But what I need you guys to do is I need you to kind of somehow, you don't have to do it the same way I do it, but you need to get some sort of a system for yourself. We noticed, you'll see the difference between an ellipse and a hyperbola in the equation. The only difference is the sign in the middle. That's it. In a hyperbola, there's a minus sign. In an ellipse, there's a plus. So those are some things you guys are going to have to look and say, okay, what kind of a shape am I even talking about? So when I look at this, I say, okay, I have my x squared plus y squared. What does this already set equal to? 1. Where is the center? Am I moving left or right from anywhere? No, 0, 0. You'll see a little more in a second, but it's the same as your parabola. If you have x plus or minus, y plus or minus something, it's moving, but it's not. So now I say, okay, is this a vertical or is this a horizontal? Well, okay, let's think about this for a second. Which one is my a squared?
9.
Why? Because it's bigger. Perfect. So write that down. Kind of give yourself an idea. Okay, well, let me look at this. Which one's bigger? A squared is bigger. If a squared is bigger, it's underneath the x. That means your major axis, where your vertices are and your foci, is going to be on the x-axis. What kind of an ellipse am I going to have here? horizontal. Good. That's very important information, guys. So a squared equals 9. So a equals plus or minus what? Okay. B squared equals 5. So b equals plus or minus square root of 5. All right. Can we go ahead and find our c value while we're at it? C squared is a squared what? Minus b squared. Okay, so my a squared is 9 minus my b squared is 5. So c squared equals 4. What's your value of c? Plus or minus 2. Right, now think everything is based on from the center. So let's look at what we have here. Let's draw a little picture. My center's at 0, 0, which we love. We said it's horizontal, right? Correct, I should say. So that means my a value, my vertices, are going to be left and right. So from the center, how many spaces am I moving to the right and to the left? 3. So I'm going to go 1, 2, 3 here. What's that point? It's 3, 0. And from the center, I'm going to go left. 1, 2, 3. So what's that point? Perfect. Good. Everybody okay? All right, now where am I going to go? What do you want to do next? Your co-vertices? All right, since my major axis is left and right, then my co-vertices are going to be up and down, yeah? So I'm going to just go up here, say this is the square root of 5, and down here is negative root 5. Yeah? Okay, so if I had to write that as an ordered pair, it would be 0, comma, root 5. This would be 0, comma, negative root 5, correct? And then where are my foci? Are they on the major axis or the minor one? They're on the major. So what color am I going to do? My biggest choice is what color. So from the center, how far do I go left and right? So I have a foci here, and I have a foci here, a focus here. And those points would be at negative 2, 0, and positive 2, 0. You guys agree? And then when you draw your ellipse, it goes something like this. Is it really, really, really hard to find the A, B, and the C value? No. But is it a lot to remember? Wait, which way do I look? How do I move? That sort of a thing? Yes. Okay, and I understand that. I do.
What are the both sides of the points?
There, if you look at the first, scroll back to the first. One more. All right, turn the page or scroll up. We're talking, now this chart to me, this doesn't tell me anything. I look at this and I'm like, what, huh? Guys, the exact same thing. Your major axis contains your vertices and your foci, right? Your minor axis, the one that's not so important, contains your co-vertices. What I want you to do is I want you to cross this out. I don't like, it's easier to memorize it or to think of it this way. And rewrite this as x minus h squared over b squared plus y minus k squared over a squared equals 1. The same premise, same exact premise still prevails. A squared, that is your major axis. That is your vertices. If the A is underneath the X, you have what kind of an ellipse? Horizontal. If the A is underneath the Y, you have what kind of an ellipse? Vertical. How has this changed from what we just did here? What's the only thing that's new? The H and the K. So instead of being at 0, 0, you guys are going to have to determine where the center is. And we can do that. We've done this a million times with parabolas. Everybody with me? All right, let's do a couple more. Let's do this one, and I'll just do 3 and 4, and then we'll stop for today. All right, first things first. I'm going to look at this and say, is this ellipse, it's an equation of ellipse, is it set equal to 1? Okay, good, so we can start. Am I centered at 0, 0? No. Where is my center, guys? My center is at positive 2, negative 1. And remember, It's opposite of what it looks like in the equation because your original standard form has a minus sign in the equation. So now I look and I say, okay, well, I need to identify my a and my b squared. Which number is bigger? 16. So this is my a squared, and this is my b squared. You guys agree with me? You understand why? Okay, so if,
What's the center? I can't see.
2, -1.
Oh, it's opposite.
Yep. So if we're talking about what kind of an ellipse I have here, a squared is the bigger number, so it's underneath what variable? The y. So this makes this a vertical. Good. Whoops. Just remember, give yourself all of these little tips to kind of make things a little easier for you. Vertical. So think about it. Think. This is a vertical. So your major axis is going to have your vertices and your foci. Which one is the major axis, the x or the y? The y, because it's vertical. Okay, good. So let's talk about our a squareds and our b squareds and our c squareds. So a squared equals 16. So a is what?
No,
Plus or minus 4. What does that mean? You're going to move plus or minus 4 from the center, right? From the center. So the last time it was 0, 0, it was real easy to just go up 4, down 4 from that point. Now you're going to have to go up 4, down 4, but from not the center. So you're going to have to do a teeny little bit of math. We'll do it in a second. So b squared equals 9. So what is b? Plus or minus 3. Okay, perfect. Let's go ahead and talk about our c value. C squared equals, what is it? A squared minus b squared. So I have a squared is 16 minus b squared is 9. So c squared equals 7. What is c? Plus or minus the square root of 7. Now we just have to do a teeny little bit of computation, okay? If I want to know, because I'm going to graph, where to put everything. Where is your center? Yeah, hang on one second. Okay, my center is at positive 2, so over 2, and down 1. Do you guys agree with me on that? There's my center. Okay, if you need to look at it in a point form, there's your center. Here's your x value, and here's your y. Remind yourself again, guys, where does the majority of our information lie? On the main, or the major, or the minor? The major. So my a value and my c value are going to affect what? Your x or your y? Your y, correct. So when you're trying to find your vertices, I'm going to add and subtract, here's my center, 2, -1. We're trying to find our vertices. I'm going to add and subtract what number? Your vertices go with what letter? A, B, or C? A. I'm going to add or subtract it to what, since I'm moving up and down? To the y. So I'm going to add and subtract here. Do you guys agree with me? So when I do that, I'm going to have vertices. Write it over here. You don't have to do everything in your head. So your vertices are going to be at 2, where? What's -1 plus 4? 3. And I have another one at what's -1 minus 4? -5. So I'm going to go over 2 and go up 3. 1, 2, 3. Then I'm going to go over 2 and down to -5, right? 1, 2, 3, 4, 5. Everybody see how we got those numbers? Okay. What else is, yeah. What else is along that vertical, that major? The foci, all right? So let's think about how we find the foci. I'll do it down here. Foci from the center at 2, -1. Again, the foci, we're moving up and down, right? So I'm adding what value to the x or the y? I'm adding what? Plus or minus square root of 7 to the y. Good. So your foci is going to be at 2, -1 plus the square root of 7, right? And 2, -1 minus the square root of 7, correct? Do we know exactly where that is? No, it's not great. Square root of 7 is in between what two numbers? What's the square root of 4? 2 and the square root of 9. So think about it. It's going to be like in between. We'll say this is 2.5, something like that. So you're going to go -1 minus 2.5, -1 plus 2.5. Just put it in the middle somewhere. It's fine. You don't have to be exact. As long as this is exact, you're fine. What's the last thing we need to plot? Your what? The co-vertices. Okay, good. So from the center, my center was again 2, -1. My co-vertices, are they on the major axis, or are they on the minor? They're on the minor, so that's going to be the opposite one that we were just talking about. We were talking about all the major stuff was up and down, so your co-vertices are going to go which direction? Left and right. So you're going to add and subtract what number? Plus or minus 3 to what? To the x. Good. So you're at 2 plus 3 is 5, -1. And 2 minus 3 is what? 2 minus 3. -1, -1. These are your co-vertices. So 5, -1. 1, 2, 3, 4, 5. Down 1. And then -1, -1. So -1, -1. And then go ahead and draw a quick little picture. It's going to go through your vertices and look something like that. Again, this is like, oh my gosh, this is so hard. No. Is it a bit of a pain in the butt? Yeah, for sure. I agree. Let's do one more and then we'll finish up tomorrow. The other tomorrow is going to be given all like the foci and stuff like that. You have to write the equation. We'll talk about that tomorrow though. Let's go. Next one. Oh, always getting curveballs here, huh? Standard form of an ellipse is x squared over a or b squared plus y squared over a or b squared equals to 1. Does this equal 1? No. My first issue is it doesn't equal 1. What I tell you to do when there's any kind of a number over there, what do? Divide everything by it. Okay? Easy enough. Now, do a little math over here. You guys already know this, but if I have x plus 3 squared divided by 4 divided by 16. If I keep change flip, do you agree that we keep change and this becomes 1 over 16? You guys okay with that? So when I rewrite this, it's really x plus 3 squared over what? 64 plus y minus 3 squared over 16 equals what? 1. All right, now we're in standard form. Hopefully, you guys are like, oh, okay, I already see this is horizontal. I see what my a squared, my b squared are. Everybody with me? Okay, good, good, good. Where is my center? It's at -3, +3. Good, there's your center. That's important. Which one's my a squared, which one's my b squared?
X is the A.
Okay, why is this a squared and why is 16 b squared? 64 is bigger, okay? So horizontal, write that down. That means all of your important info, if you need to, write down vertex or vertices and foci are on the x-axis, right? Or on the x. That means you're going to add and subtract for vertices and foci to the x value. If you want to say your co-vertices on y, remind yourself you're going to find the co-vertices, you're going to add and subtract to the y. It's always good to write yourself little notes. So now let's go through the math to just find the numbers. If a squared equals 64, what does a equal? Plus or minus 8. So from the center, to find the vertices, you're going to add and subtract 8 to what number? 3 or -3? Look how easy this was to figure out. When you've written everything down. Look, I said, okay, to find the vertices, I'm going to add and subtract to the x so I could see, oh, okay, look, I'm going to take 8 and say 8 plus -3 and -8 minus 3. You know what I'm saying? Like, give yourself some hints. So if I'm going to find my b value, well, b squared equals 16. So b equals plus or minus 4. So I'm going to do what? Add and subtract 4 to the y. Look, guys, look how easy that is. If you just tell yourself, okay, where are my vertices and my foci? The x to the y. That's where I add and subtract. Where is my covertice? The x to the y. That's where I add and subtract. It makes your life easier, I promise. So let's find the c value. C squared equals a squared minus b squared. So c squared equals 64 minus 16. Do we already have this number already? So c equals plus minus 4 root 3. Okay, not to throw, I just want to say this. I told you guys an ellipse, right? An ellipse has a plus sign in the middle. And then in this equation, it has a minus sign, right? A hyperbola is the exact opposite. Next week, we do a hyperbola. It's going to be like this exact thing, but there's going to be a minus sign in the middle up there. And then in the c squared, a squared, b squared formula, it's a plus sign. It's always the opposite. But I digress. Okay, so let's talk about. All right, let's find the vertices first. Vertices. And I'm going from my center, 3, negative 3. So we said again, look, draw yourself an arrow. Tell yourself, remind yourself, my vertices are on what axis? The x. So I'm going to add and subtract what number to my x value? Plus or minus 8. So my vertices are at what? 5, 3, agreed, and negative 11, 3. Perfect. What's negative 3 plus 8?
Why is it 5?
What's negative 3 plus 8?
Oh, that's negative 3. I wrote it wrong.
Okay, that's okay. Just stop yelling at me. I'm just kidding. You're not yelling at me. All right, where's my foci? Again, from the center, negative 3, 3. What number am I adding or subtracting into what? Plus or minus 4 square root of 3, right? All right, this isn't going to be pretty, so it's no big deal. So I'm just going to write negative 3 plus 4 root 3, comma 3, and negative 3 minus 4 root 3, comma 3. That's totally fine. As long as you're showing me that you're adding it and subtracting it to the correct value, the x to the y, I'm fine. And then how do we find our covertices? My covertices from my center is negative 3, 3. Well, we've been adding and subtracting to the x because that's our major. So now I'm going to add and subtract what value to what letter? Plus or minus 4 to the... Plus or minus 4 to what? To positive through the y. Okay, so my covertices, I'll call them CVs, are at negative 3. What's 3 plus 4? 7. And at negative 3, what's 3 minus 4? Negative 1. Now, if you just look at this and try to do, whoa, why did it get so tiny? All of it in your head at one time, you are never going to get this right. My suggestion to you is if this is a multiple choice test, I would not even look at the answer choices. I would find all the information and then find the answer choice that matches. Because if not, you could drive yourself crazy. Yeah.
So for the coding test, is it going to be like, oh, you're going to have to, like, where is he with the
I have absolutely no idea. As soon as I know something, I will let you know something. All right, so let's draw a quick little picture, and then we're done for today. All right, where's my center? Negative 3, 3. So 1, 2, 3, 1, 2, 3. All right, there's our center. Where are my vertices? Where are my vertices? At 5, 3, okay. So 1, 2, 3, 4, 5, 1, 2, 3. And where? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3. All right, agreed, good. Where are my co-vertices? -3, 7. So 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And then -3 what? -3, -1. And then your foci are going to be somewhere in the middle, yeah? Okay, I'm fine with that. So, something like that. And then we connect our vertices, and whoops, why'd I pick that? Then we connect our vertices and our co-vertices. That's not the best oval or ellipse I've ever seen in my life, but it's close. Okay, how do we feel? Little better than the first one? A little bit? What's really important for you guys to identify first? The center, good. It's important to find the center. It's important to then say, okay, which is the major axis? Which number, which denominator is bigger? That's going to determine if it's vertical or horizontal. Then you just figure out your A, B, C, and you go from there.